Good evening. Let me take you through this question. You are provided with the following solutions: 1 molar HCl solution M2, 1 molar sodium hydroxide solution M3. You are expected to determine the molar heat of neutralization of hydrochloric acid. Proceed as follows. Measure 23 centimeters cube of M2. Remember, M2 is hydrochloric acid, and put in a 100 centimeter cube or milliliter beaker. Measure its temperature and record in the table below under first column. By use of a measuring cylinder, measure 5 centimeters cube of M3 and add to M2 in the beaker. Stir with the thermometer. And record the final steady temperature. Continue adding 5 centimeters cube at a time and recording the temperature till 35 centimeters cube of M2 has been added. Complete the table below. So this is volume. So it means it is sodium hydroxide reacting with hydrochloric acid. Actually, the reaction produces heat. Heat is evolved. Therefore, initial temperature when M3, it is only when M3 has not been added, the temperature of HCl is 22. The 22 is 22. 23 centimeters cube of M2 is, the temperature is 22. After adding 5 centimeters of M3, which is sodium hydroxide, temperature rose to 24. After adding 10 centimeters cube, temperature rose to 26, and then the graph continues up to 35 centimeters cube of sodium hydroxide is added. So when the temperature reaches 28, it remains constant and then it starts decreasing. So this is the trend that is expected. So the temperature increases, reaches a point, it becomes constant and then decreases. That is what we call the trend, and it is marked. So it is important to record temperature to 1 decimal place, because sometimes you can get your temperature reading to be 22.5 and you have not included the decimal point in your table. So it is important to record temperature to only 1 decimal place. It is okay. So that is the temperature we are going to use to plot a graph of temperature vertical axis against volume of sodium hydroxide added. So vertical axis is the y-axis, and the against this one sodium hydroxide will be the x-axis. So let us plot the graph. To save our time, now we have the graph of volume of sodium hydroxide added, temperature. So it is temperature against. Temperature is the y-axis, the vertical, and this is the x-axis, the horizontal. So you must remember to label the graph for you to score the marks of labeling, and then the scale should be a good scale. You should cover at least 3/4 of the graph provided. Because temperature, we start at temperature around 20 and to above, so we break the graph. I have broken the graph and started my recording from 21 and then 22 going up. Volume will start at 0 and then 5 to 35. So let us plot the graph together. When the volume added is 0, the temperature is 22. We record that. When the volume added is of sodium hydroxide is 5, the temperature rose to 24. So this is 24 here. When the volume 10 centimeters is added of sodium hydroxide, the volume rose to 26. So 26 is here. 26 is here, so you come across and then you put a mark there. When the volume used is 15, the temperature rises to 27, so you find 27 is here. When the volume added is 20 centimeters cube, then temperature rose to 28. When the volume is 25, when temperature is 25, the temperature remains 28. When the volume is 30 temperature decreases to 27. This is 27 here. And then at the 35, the volume, when the volume is 35, the temperature decreases to 25, 26 here. So that is our graph. So you take your ruler. If I put the first point here and the last point there, I'm going to draw only 2 points, right? What about if I put this point and the last one? I'm going to use only 2 points. But what if I use this 1, 2, 3? So this is the correct way now of drawing it. I'm going to use the 3, 1, 2, 3 points. Now this one will give me the best line of fit. Therefore, draw your line like that. Here there is no problem. We draw our line there. Very good. So once you have done that, you can join this one here. There's no problem. We have this kind of graph. So this graph will not give us the correct, the maximum. So what we do, this line we extrapolate. We increase this line this way and we increase this line this way until they meet somewhere. Where they meet, we get the maximum temperature raised, and then we will get also the volume of sodium hydroxide that reacted with 23. That one. So let us extrapolate. So you put your lines like that and then use a dotted line like that. Also join this one, dotted line. Now you see this dotted line, it is meeting at this point. So when you come across here, the maximum temperature is 28.5 because this one is 29. So the maximum temperature is not 28, right? It is now 28.5 from the graph. Very good. So let us go straight to the question. By doing so, you score your marks, 3 marks. From your graph, determine the volume of 1 molar sodium hydroxide needed to neutralize 23 centimeters cube of 1 molar. So you use your graph because you have been told from the graph. From the graph. So where we have the maximum temperature here, that will give us the maximum volume. So for you to get the volume, you stand at that temperature, you draw a dotted line downwards. When you draw this line, it shows the person who is marking that you used the graph. So this line here will show him or her that you used the graph. That's why they say from the graph. If you don't draw this, you don't score that mark. So if I read my x-axis, this is 21. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is around 22.5. Because this is 25 and this is 20. 4 small unit squares represent 1 unit, 1 by 1. Therefore, this is 21. 1, 2, 3, 4, 1. 1, 2, 3, 4. 1, 2, 3, 4. So this one is 21, 22 and a half. So the volume now, the volume that neutralizes 23 is 22 and a half. 22 and a half. So you go back to your script and then you say the volume is 22.5 centimeters cube from your graph. From your graph, determine the rise in temperature. So we are going to use our graph to get our temperature. This is our graph. The maximum temperature attained is at this point where the extrapolated lines meet. So from here we come across. So to show the examiner that you used the graph, you must draw a dotted line from the extrapolated where the two lines are meeting here to the y-axis. You must draw this. And this now shows the examiner that you used the graph. So that's our maximum temperature. So our maximum temperature is 28.5. Our initial temperature from here you can see is 22. So 22. This one it gives us 6.5. 6.5 degrees Celsius. That is the temperature attained. Now calculate the amount of heat evolved in the above reaction. Take specific heat capacity of solution to be this, and the density of solution is this. So now we want to calculate the specific heat capacity, but we know heat change. We want to know heat change. Calculate the amount of heat evolved. So heat change equal to mass of the solution times specific heat capacity times temperature change. We know that. Mass of the volume was 23 plus 22.5. This is for the sodium hydroxide. This is HCl. So the total volume is 45.5 centimeters cube. So because we have been given the density here, the mass is going to remain 45 grams. So we divide by 1,000 to change these grams into kilograms. Specific heat capacity we have been given 4.2 times heat temperature change is 6.5. So you use your calculator. So this one will give us 1.2422 kilojoules. Calculate the number of moles of HCl used. The HCl, we know the volume is 23 centimeters cube that was used, but we know the molarity of HCl is 1. 1 mole means that the number of moles in 1 liter is 1. So we come back here. We say that 1 mole simply implies that this is the number of moles, implies that 1 mole is equal to 1,000 centimeters cube. We will ask what about 23 centimeters cube that was used. So it is 23 times 1 divided by 1,000, and this one will give us 0.023 moles. That is the number of moles of HCl that was used. Hence, determine the molar heat of neutralization of hydrochloric acid, molar, for 1 mole. Molar means we want to calculate the heat of neutralization for 1 mole. But we know the number of moles that produce this. So this one, there is something we know here, that this kilojoules was produced with these moles. Now what about we are saying that this kilojoules was produced with this mole. What about 1 mole? So we are going to say 0.023 moles produced 1.6 kilojoules. What about 1 mole? 0.0023 moles of HCl produced 1.2422 kilojoules. 1 mole of HCl will produce how much heat? So it is this times, that's 1.2422 divided by 0.023. This one will give us 54 kilojoules per mole. Kilojoules per mole. But we know that the reaction was exothermic because the temperature was increasing. Therefore, we have to include the negative for you to score the full mark.